All right, time for 5.2. Again, we are now looking at the derivative of exponential functions. This time, it's going to be a more general case. In 5.1, we looked at how to find the derivative when the base is a very specific value e. Now we're going to do when it is any value b. So it can be any number. It could be 7 or 7.2 or negative 200 million. The point is, when you have a function, an exponential function, with any number as the base, then you would take a different approach to finding the derivative. It's the same approach that we did in 5.1 with an extra little piece that we have to do. To find the derivative, we're going to take b to the power of x is going to be the same thing, but this time we're going to multiply by ln of b. So the derivative of b to the power of x is b to the power of x multiplied by ln b. So what does that look like? With a quick little example, if we have y is equal to 4 to the power of x, y prime will be 4 to the power of x multiplied by ln of 4. It's just ln of the base. So if you have a more complex question like y is equal to x squared times 4 to the power of 2x, again, to find the derivative of the first one. So 2x times 4 to the power of 2x plus x squared stays the same. Now we find the derivative of 4 to the power of 2x, which will be 4 to the power of 2x multiplied by ln 4. And then you multiply by the derivative of the exponent, which in this case is 2. And then we can go ahead and simplify that as well. So when you're looking at the derivative of an exponential function, of any exponential function, it's the original function as it is, multiplied by ln of the base. The reality is this method can actually be applied to 5.1, where in 5.1 we had f at x is equal to e to the power of x. This is actually e to the power of x times ln of e. But ln of e is the same thing as log of e with base e. So because anytime you have log with base e, it becomes ln. So log base e of e, when these two are the same, this is equal to 1. So this value here simply cancels out and becomes a 1. So all you need to know is e to the power of x. What's my point? The derivative of any exponential function is the original function multiplied by ln of the base. And then obviously we can get a bit more complex questions that deal with derivative of using power rules and chain rules and a combination of functions. So let's do one other example together, and that'll be it for this lesson, inshallah. 3x minus 2. Okay, taking one from example 1 in the textbook, we have y is equal to 5 to the power of 3x minus 2. This is clearly an exponential function because the variable is in the exponent. Your base is a number, 5. To find the derivative, what do? This is chain rule. So you have a function, 3x minus 2, inside of another function, 5 to the power of something. So we take the derivative of the outside function first, which is 5 to the power of 3x minus 2 multiplied by ln of 5, which is the base. We ignore the exponent. And then we multiply by the derivative of the exponent, which is 3. So our final derivative would be 3 times 5 to the power of 3x minus 2 times ln 5. Right? I guess let's put that in brackets just to avoid any confusion. Okay, very straightforward. We're still in the easy part. Going forward, we'll get to the derivative of trigonometric functions, but for now, enjoy.